Okay. In our notes today, we are going to convert things from grams to grams now. I think it's exciting. Huh? 23. So you're on page 23 of your interactive notebook. I want you guys to try your best. Now you're going to take the information that we've looked at already, stuff from previous unit, and we're going to apply it to the stuff in this unit. I'm going to give you all the information you need, and I want you guys to see if you guys can connect the two dots. Something we've never done before, but I'm going to see if you guys can make this connection, okay? Here we go. Our equation that we are going to use, I want you guys to first balance it. You can tell me what kind of reaction this is as well.
Can you write it a little bit further apart?
Sure. Yep, grams to grams. So we'll entitle it grams 1 to grams 2 because you're going to be converting between grams of one substance to grams to a second substance. In this case, we're going to take 25 grams of NH4NO3. And you're going to convert it to grams of water. Now again, we've never done this full step before, but you have all the information to you available using the things that you've learned before, things we just learned, and bringing them together. I'm not saying it's going to be easy, and I'll be walking around to help you a little bit, but I will go over it in just a little bit of time. But I wanted you guys to get practice at it before I show you how to do it. So give it your best shot. Try to get as far as you can. And when you get stuck, I will try my best to come around and help you. When there's too many hands going around, I'll stop you guys and we'll start doing it. Yeah, you got to balance it first. Any other questions? What kind of reaction is this taking place? Decomposition, that's right. Kind of like most of your brain cells, after the weekend. They start decomposing and forgetting all the information you just learned in chemistry. Sad but true. It even happens to me. Yeah. Izzy.
How many steps should there be?
That's a good question. I'm letting you guys try to figure it out, but I am going to give you the helpful hints at the end of this thing, okay? So I'd like you just to see how far you can get on your own. And then I will do my best to explain it to you as I can. So how smart is Cassie? That's what we're trying to figure out.
Pretty smart.
Pretty smart. As soon as she starts writing things on her paper, she'll show her smartness. Keep writing. We're trying to solve it.
Are we trying to solve it now?
We're trying to solve it now, yes. There we go. So you can have equal amount, oh, there we lost it. We have equal amount of nitrogen on this side as we do on this side, don't we? And so if we have nitrogen, how many nitrogen are on the reactant side over here? 2. How many are on the product side over here? 2. Do you guys see this? Okay. Then how many hydrogen do you have on the reactant side? How many do you have on the product side over here? 2. How can I make 4 on the product side? You add a 2 over here. Is anybody unclear about what I'm doing? Okay. So we add a 2 right there. That gives us 4 hydrogen. 2 times 2 is 4. And 4 hydrogen, right? We didn't mess up the nitrogen. We still have 2 nitrogen and 2 nitrogen, which brings us to the oxygen. How many oxygen do we have right here? How many oxygen between these 2 molecules do we have? 3. This thing is in balance. Does anyone not see how this is balanced? Now, literally, since probably mid-January, I've been trying. We learned this step also at the beginning of the school year when we were doing dimensional analysis. Anytime you see the word convert, that means automatically, even if you don't know how to do this kind of problem, you should always write down what's given and set up dimensional analysis. At the bare minimum, you should be able to do this. "25 grams of NH4NO3, and then to set up your dimensional analysis, you just do this. You should have that much set up. After that, things get a little bit more complicated. Does anyone have any questions so far? Okay. Now watch this, guys. For those that don't know what you're doing and how to proceed from here, you always start off with what's given here, grams of NH4NO3, right? You literally, all you need to do is put right below here, whatever's here, right in here. And you just write in grams of NH4. I'm just going to abbreviate it to make it a little bit shorter. Instead of saying NH4NO3, I'm just going to put NH4. I just put grams of NH4 right down there. When you're dealing with grams, anytime you have grams and you don't know what to put in there, the very first thing you should think of is the molar mass. Yeah. The molar mass. In your molar mass, all you need to do is add up all the atoms in the molecule. So you add up the mass of 1 nitrogen, 4 hydrogen, one more nitrogen, and 3 oxygen. You look at your periodic table, you look at the masses of them, and you just add them all together. Does that make sense? Do you understand how to do that? Does anyone need me to walk you through that? Do you? When you add up all the masses from the periodic table, what does it add up to be? What is it? What'd you guys get? 80.06, that's right. So you put in 80.06 grams of NH4. That's just all these masses when you look at the periodic table, you just add them all up, and they are equal to this. Every single time that you're doing molar mass, and you get the mass, you got to remember that's always equal to 1 mole. Now, we are not where we need to be yet. We don't have grams of water yet. So what you need to do now at this point is to convert these moles of NH4NO3 to moles of water. That's what our mole ratio step is. This is the new thing, the new part of the chapter that we've learned. It is mole ratio. So moles of NH4 go on the bottom. You know how I know this? You see the moles of NH4 up here? You just put moles of NH4 down here. That way we can cancel them out. Just like the grams of NH4 cancel out, we can now calculate moles of NH4. I'm trying to convert it to moles of water, so that goes on top. Converting it to moles of water, so that needs to go on top. What I'm trying to cancel out on the bottom, what I'm trying to convert it to on top. Okay? So now when you have moles over moles, we use our mole, this is our mole ratio step. Only in the mole ratio step do we use this thing up here. So how many moles of NH4NO3 do I have? 1. How many moles of water do I have? 2. Anybody confused to where I got those numbers from? Tristan? In the mole ratio step, okay, where you got moles over moles like this, when you're converting moles of this to moles of this, you use your equation up here and look at the coefficients to tell you what the moles that you put in here. So you have 1 mole of NH4 because you got 1 up here coefficient. You got 2 moles of water because you got a 2 coefficient. Any other questions, guys? Is there anything you don't understand in here? Okay. Then the final step, the one part that you have to put together from the previous stuff that we've studied, that we've never done in this particular way before, is converting these moles into grams now. And so what I'm going to do is I have to get rid of these moles of H2O, because that's not what I want for my answer anymore, is it? I want grams of H2O. So I'm going to have to put 1 mole of H2O. I want to convert this to grams, right, of H2O. And anytime you think of mass or grams, what should be the thing you think about? Molar mass. And what is the molar mass of water? 18.02. Very good. 18.02 grams of water. Okay. Yay. Yes. Now, we've gotten this whole thing set up. We got the units we want. Grams of water in our answer. Because I can cancel out these moles of water. I'm left with grams of water as our final part. Now we can just do the math. You take 25, you divide it by 80. You multiply it by 2, and then you multiply it by 18.02, and what should you get for your final answer? 11.25, very good. 11.25 grams of water. And that is your final answer. If you're not getting this stuff, guys, I highly recommend you keep looking at your interactive notebook. If you have to at home, go back through this. You can watch what we're doing right now. It's not very exciting, but at the same time, at least you can get that comprehension going if you've forgotten something. The more you practice it, here's the idea. We go over about 15 minutes of lecture. Hopefully not more than that, sometimes a little more. But then you practice it in class by doing some of the worksheets. Then you do a couple problems at home. And hopefully by then you start to remember how to do these things. But use your interactive notebook to help guide yourself through these problems. Okay? Now, next part. Just a bit of a quick review and a way to help yourself through any of these problems in the last 2 units that we've done. We're basically complete with everything that we need to know for this unit. There's only one little small tweak that we need to look at, and we'll do that tomorrow. But the rest of it's pretty much set up and ready to go for you. It's just now a matter of practicing and practicing until you can get comprehension and know how to do it. Alright. In review, you guys have seen this table before. You guys have all seen this table before, right? Yeah. If you understand it, it can help you through any conversion for any kind of substance, one substance. So like if we're trying to convert things from grams of water to liters of water, or liters of water to molecules of water, or molecules of water to grams of water. No matter what you're trying to do, this table will help you through one substance. So this will help you through any time that you have to convert things from one thing to another. And if you guys remember, between each one, everything is equal to 1 mole, right? 1 mole. 1 mole equals the molar mass. 1 mole equals 6.02 times 10 to the 23rd. And 1 mole equals 22.4 liters. That will help you guys. And plus, if those that did not do well on your mole test, you can retake this test, because what we've been doing in this unit helps you in the past unit. So if you're starting to understand, starting to get the patterns that are going on here, you can use that to help you with the test that you did before. Retake that. Helps you to study for this test that's coming up. Our next retake is next Thursday. Highly recommend that you guys work on this, okay? If you can. Alright, now the new table, the one that will help you between when you have different substances, like we just did Na4 and O3 and we converted it to grams of water, right? A new table to help you out will look like this. So we looked at steps where we converted grams, liters, or atoms to moles, right? We always converted first things to moles. I put a little 1 in here to represent this is my first molecule. When I'm trying to convert grams, liters, or atoms, the first thing I always do is convert it to moles, right? And in these steps, it's always equal to 1 mole. The next step in our table is we now want to convert these to moles of something new. So you want to convert it to moles of substance number 2. When you're doing this step, this is the only time it's not going to be equal, well, it could be equal to 1 mole, but it can also equal to more than 1 mole, and this is where we use our mole ratio step. So we can convert it from grams, liters, or atoms to moles of one substance. Then we convert it from one substance to a second substance. And once you've converted it there, you can now convert it back to grams, liters, or moles of your second substance. And again, everything in this step is going to be equal to 1 mole. I like to give you guys some little graphical representation so that you can plop these on your test, and hopefully if you can remember what they mean and how to convert things between them, you'll know exactly what to do on your next test. For example, let's say we first started off with moles. We converted moles to moles, right? That's the first part of this unit that we did. You guys seem to get that. When we went from moles to moles, we just did one step, didn't we? One step from here to here. In any question now on your test that gives you moles and says to calculate moles of something else, you know you start here on moles of 1, you convert it to moles of 2. That's just one step you got to do. The next thing that we did this in the warm-up, we also did this yesterday, we started looking at how to calculate grams to moles of something else. And so to do that, we went from grams of substance 1, we had to convert it to moles of substance 1, and then to moles of substance 2. And what you just learned today is how to go from grams of one substance to grams of a second substance. And you go from grams to moles of 1 to moles of 2 to this thing. And you can see there's 3 steps involved, 1, 2, and 3. You just follow the table depending on where you are. That will tell you how many steps that you need to do. So, was it Izzy and Bidriana, you guys were asking me about how many steps there are in the problem that you were doing? Was you guys ever asking me that? No? Who was it that's asking? Maybe it was another class. But you always know how many steps to put out because you can just look at this table. What information is given to you? Was it the moles? If it's a mole and you have to find liters, well then we can go 1, 2. I know I have to put 2 little brackets out, 2 steps. If I have grams to start off with and I need moles of something else, again, 2 steps, 1, 2. Tells you how many steps are going to be. All right, before I bore you enough, is there any questions that you have for me about this? Yeah, I'll go back in just a sec. Alright, so what I'd like you guys to do is if you guys will work on your worksheet, make sure you do the first 10 problems in 11-2. I'll be walking around. If you have questions, I'll be able to help you as much as possible. Look through your notes, guys, because that's really where all the key information is to help you through these problems. The only part that might be really difficult is trying to figure out what the exact equation is from some of the word problems. That will be hard. The rest of it, I think you guys should be able to do by now. Sound good?